Hello students, welcome to our YouTube channel Experience Tutor. Today we will discuss class 12th physics revision notes for exams chapter 1 electric charge and fields. Welcome message. This is our welcome message. Before we start, we have a humble request to subscribe, like and share this channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded. Thank you for your support. Let us begin with the lesson. So today's topic is electric charge and field. So chapter 1. Now, what is electrostatics? Electrostatics is the study of charges at rest. Is the study of charges at rest. Electro means charge and statics means rest. So charges at rest. Next, and how many ways we can do? What are the ways we can charge a body? So charging a body can be done by friction, next by induction, and by conduction. Now we'll study little more detail about friction. How we charge a body with friction, by friction. So frictional electricity. Frictional electricity. So what is frictional electricity? So frictional electricity is the electrical produce is the electricity produced by rubbing two suitable bodies and transfer of electron from one body to another. For example, silk plus glass rod. Second example, ebonite. When ebonite is rubbed with phenol. Phenol. So let us see the first example. What happens when glass rod is rubbed with silk? When glass rod is rubbed with silk, electrons in the glass rod electrons in the glass rod are loosely bound in, in it, then the electrons in the silk. When when so when glass and silk are rubbed together, the comparatively loosely bound electrons from glass get transferred to silk. Silk. As a result, as a result, glass becomes positively charged and silk becomes negatively charged. Charged. Now let us see the second example. Second example is ebonite is rubbed with phenol. So ebonite plus phenol. Electron in 4 electrons in electrons in 4 are loosely packed, bound in it. Then electrons in ebonite. So when ebonite is rubbed with for the comparatively loosely bound electrons from fur get transferred to ebonite. As a result, ebonite becomes negatively charged and fur becomes positively charged. Now, so if we draw the structure, then we can find it that, say, this is ebonite and this is the atom of ebonite and this is the atom of fur. So what happens mm, in fur, electrons in fur are loosely packed. Here electrons are loosely packed. So whenever in comparative to ebonite, so whenever ebonite and fur are rubbed together, then what happens, these loosely uh, mm, bounded electrons moves to ebonite. So it moves to ebonite and ebonite becomes ebonite is more electron rich now, means it has more negative charge than before. It is rich in electron, so it becomes negatively charged. But for before donating the electron, it was neutral, but as soon as it donates the electron, it has more positive charge due to nucleus. So it is positively charged. This is a simple concept. Same thing happens with the silk and rod. Now, it is very important to know that electrification of a body, whether positive or negative, is due to the transfer of electron from one body to another body. So, that is, electrons are transferred from one body, then the deficiency of electron makes the body positive. On the other hand, if the electron is gained by a body, then they have excess of electron and makes the body negatively charged. If two bodies from the following list are rubbed, then the body appear early as a okay. Now take let us take few of the examples. If we rub two bodies, what will happen? Now let us see few of the examples. For example, we have just studied glass plus silk. If we rub, then what happens? Glass becomes positive and silk becomes negative. Similarly, wool plus funnel, if we rub, then if we rub wool or funnel, uh, just some mistake here. If we rub wool or funnel with amber, with ebonite, or amber, or rubber, or plastic, then what happens? Wool or ebonite, wool or funnel becomes positive charge, becomes positive, and ebonite, amber, rubber, plastic, everything becomes negative. Now let us take the next example. When ebonite is rubbed with polythene, then ebonite becomes positive and polythene becomes negatively charged. Now, if we rub dry hair with comb, then dry hair becomes positive and comb becomes negative. Now we'll study about properties of charges. So, properties of charges. First property, there exist only two type of charges, namely positive and negative. So only positive and negative charge exist. No third type of charge is there. Like charge repel, unlike charge attract. Unlike charge attract, attract. Third, charge is additive in nature. Nature. For example, if we have plus 2 coulomb of charge plus 5 coulomb of charge minus 2 coulomb of charge, then total is plus 5 coulomb of charge. Next, charge is a scalar quantity. Charge is a scalar quantity. Next, fifth, charge is quantized. Is quantized. Quantized. That is, electric charge exists electric charge exists in discrete packets. In discrete packets rather than rather than in continuous amount. It can be expressed in integral multiple in integral multiples fundamental electronic charge that is E is equal to 1.6 into 10 to the power minus 19 coulomb. So Q is equal to Q plus minus NE, where N is equal to 1, 2, 3, 4 and in this way. Now the next property of charge, sixth property, charge is conserved. Conserved, that is, the algebraic sum of positive and negative charges in an isolated system remains constant. Remains constant. So we can say that when a glass rod is rubbed with silk, negative charge appears on the silk and equal amount of positive charge appears on the glass rod. The net charge of glass rod silk system remains 0 before and after rubbing. It does not change with velocity also. So this is the example. So let us consider a system of glass rod and silk atom. So when glass rod is rubbed with silk, the negative charge appears on the silk. So this becomes negatively charged, and glass rod becomes positively charged. But so if the negative charge here in before that it was neutral, both were neutral. So if if the negative charge increased by two column here coulombs here in silk, then equal amount of positive charge has developed, that is 2 coulomb of positive charge has developed in the glass rod. So this whole system is again neutral. This whole system is again neutral. Now let us see the next topic. One note, small note, then we'll close this video. We'll next start with the next topic. Charges can be detected by electroscope, by instrument called electroscope. Now let us study about quarks. Quarks. According to recent research, it was evident that protons and neutrons consist of another fundamental particles called quark called quarks. So a proton and neutron consist of three quarks each. These quarks are of two types. Types. First is the quark possessing possessing plus 2 upon 3 electron charge is called an up quark or U, and the another having having minus 1 upon 3 E charge is called a down quark D. Therefore, the composition of proton is indicated as U U D, and composition of neutron is indicated as UDD. Matter is in this way is formed of such quarks and electron. In this way, matter are formed of such quarks and electrons. Until now, we haven't seen any independent existence of quark. Now, experimental proof of conservation of electric charge. So let us consider a highly energetic photon enters in a box. A photon is a chargeless particle. So this is chargeless particle. So as soon as it enters into the box, it produces a an electron and a positron. It produces a electron and a positron. After the pair these pairs are produced, the isolated system, the net charge is 0 because the charge on the electron and positron are equal but opposite type. So the initial charge of the system was also 0. Thus, it proves the conservation of electric charge. So this was the experiment. Now we'll study about charge by conduction. So charging by conduction. So let us take two spheres with a insulator base. One sphere have a plus q charge, positive charge, and other sphere is chargeless. In the second step, we connect these two spheres with a conducting wire. After some times what we see, the chargeless sphere is charged by positively charged. So if the initial charge of was plus q, then now the charge sphere charge is reduced to q by plus q by 2, and on the other hand the chargeless sphere gained plus q by 2 amount of charge. This explains the phenomena of conduction or uh, charge by conduction. Charging by induction. So in this method, the charge body does not lose its own charge without coming into physical contact with the other object. It will induce opposite charge in that. So in the picture, you can see 4 steps. This is step 4. In the first step, let us consider a isolated metal sphere. The net charge of the sphere is 0. In the second step, we bring a negatively charged plastic rod in front of the sphere but do not touch the sphere. What happens? The free electrons move on the other side of the rod of the sphere because of repulsion, and by a conducting wire we grounded those electrons from the other side of the sphere. Now the sphere become positively charged, and the third step we can see it, and in the fourth step it is evenly distributed in the among throughout the sphere. So this explains the charging by induction. This is the end of today's topic. Please subscribe, like and share our channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification. Thank you for your support.